Okay, this set question here. Simon bought a radio for £42 and sold it. Simon, hey, bought it, sold it for 12%. How much did he sell it for? Right, so, okay, £42 he paid for it, and then he sold it for 12% more. So if you had a calculator, the multiplier would be 1.12, but you don't have a calculator. This is a non-calculator paper. So I need to work out, first of all, 10% of 42, which is 4.2. And then, because it's 12%, if I go for 1%, the reason 1% is easy because the decimal jumps back another point, so it's 0.42. And therefore 2% of 42 is going to be double that, 84p. So now I'm going to add it all together. I want the 10 and the 12, so I don't care for that one anymore. So adding that together, that's, put the pennies there, so that's 20p plus 80p, that's £1. So it's £5, 4p. Sounds funny, isn't it? £5, 4p. There you go. And that's how much you sold it for. Cool. Then it says a house was valued at £2,300. This is an increase of what? Oh, on a valuation of 200,000. I thought it was like a £200,000 increase. Like, that's nice. So basically, the difference, if we want to work out here a percentage increase, it's difference divided by original times 100. So you've got to remember that difference. So in this case, it's 30,000 over the original 20,000 times 100. So all these flipping noughts, let's get rid of some of them. 3 of those, 3 of those, that fella, and then I've got 1 of those there, so that's going to be 30 over 2, 15%. There you go. But much easier than you thought, really, isn't it? It says Marie guessed that there were 63 oranges in a box. When she counted, there were only 72. Why does it say only? That's weird, isn't it? Because you actually got more than what she thought. So what was her percentage error? Right, again, the same idea, difference over original times 100. So she thought 63 and there were 72. So that is a difference of 9. So therefore, difference over the original. So she guessed that, her error, the original is the 72. That's where it can get confusing, times 100. Now I know that 9 is going to 72, 8 times. So it's 1 over 8 times 100. Basically 100 divided by 8, which is 50 divided by 4, which is 25 divided by 2, which is 12.5%. Okay. And then lastly it says here, Crystal sold a car for £880, making a 10% profit. What was the original price she brought it for? So be careful with this one. So that's what she sold it for. Now that equals 110% of that's 110% because you did a 10% increase. So what I need to do now is find out effectively what 100% is. Now don't take 10% of that 88 and take it away. That ain't gonna work. So what I need to do is find out what 1% is. But I can see here, look guys, I can work out 11% is 88, yeah? So 11% is £88, and in my gut, I'm seeing that 1% is 8. So £8 is 1%, because 88 divided by 11 is 8, yeah? And therefore 1% is 8, so times it by 100, originally it was £800. So that's pretty good. Let's see, what's the next set of questions we can ask you? It's on ratio. Here we go. Move everything around. Bye you. Hello you. Ratio, like ratio actually. A teacher always arranged the content of each of his lessons to year 10 as teaching and practicing learnt skills in ratio of 2 to 3. So I'm going to do T to P, 2 to 3. If a lesson lasted 35 minutes long, how much teaching should he do? Okay, so if the total is 35, how many parts do I have? Well, I have 5 parts. Okay, and that's a total of 35 minutes. So therefore 1 part is a fifth of that, 7 minutes. And they've got 2, so that's 14, and they've got 3, that's 21. And the question asks, how much teaching? Well, 14 minutes teaching. If you decided to teach for 30 minutes, how long would the lesson be? Okay, so slightly different now. If it's here, if this is now 30, what would that be? And the combined would be the total length of time. Well, I can see if 2 is 30, then 1 part must equal 15 minutes, mustn't it? If 2 parts equal 30, 1 part must be 15. And if they've got 3 parts, that must be 45 minutes. And therefore add half an hour plus that. That's effectively half an hour plus 15 minutes. So half an hour, 15 minutes, 1 hour, 15 minutes. Okay, job done. I'll post this. Well, no, let's just go another video. Let's just do another one quickly. Recurring decimals to fractions. Ooh, right. Okay, recurring. Are these recurring? No, that ain't recurring. Where's recurring? Well, let's just look at the question here. It's disappeared. Can you believe they put a man on the moon? Right, okay. Convert the following into a single fraction. Oh, yeah. Okay, here goes. Oh, look, here we are. So convert the following into a single fraction. Right, this is interesting. Okay, so we know that 1 term of this is 0.6464 ... It's always going on. Now, in order to do this, I need to take 1 cycle out, and I can see there are 2 here before it starts cycling again. So I need to take those 2 out. By doing that, if I times all of this by 100, I then have 100n, and that would equal 64.6464 ... Do you get me? I've taken 1 whole cycle out. Now look what I can do. If I put 1 little n underneath that, 0, 0. Now watch what I can do. If I was to take away 100 from 1 from 100, I left 99n. And look how amazing. This cancels out like this, boom, boom, boom. And I'm just left with 64. So therefore, I can write 1n. Instead of writing it like that, I can write it as 64 over 99. And then I've got to think, can I cancel it down? No, I can't. And that's how you do that. Really nice question. Okay, hope that helps. See you next lesson.